All right, sketch by hand the graph f of x is equal to e raised to the x. All right, so simplest way to draw this is anything raised to the 0 is going to be 1. So starting off here, that's one of our anchor points. And because this is a positive exponent, anything below 0 is going to bring it closer and closer to 0, but never quite touch it. So it's going to be like that. And roughly, so E is 2.718, just a little bit below 3, so it's going to be somewhere right around here for 1, raised to the 1. We can kind of see it's going to look something like this. Maybe a little more bowed out. Probably a little steeper. Something like that. Okay, and now, so what type of functions are f of x equal e raised to the x, and g of x is x raised to the e, and then compare the differentiation formulas for f and g. So f, I'm going to write this down. So this is part B. F of x equals e raised to the x is an exponential function, because every value of x that you move over, it increases x increases as the exponent, not e. E is your base. And then g of x is equal to x raised to the e as a power function. And the reason for that is your exponent stays constant, but your x increases. Okay, so now differentiating these. So f prime of x is just equal to e raised to the x. It's a nice thing about e-based differentiation. And then g prime of x is equal to e x raised to the e minus 1, which is essentially equal to e x to the e over x. Okay. All right, so f prime of x is equal to f of x for this, and g prime of x is equal to e times g of x over x. All right, so f of x is equal to e raised to the x. Functions grow more rapidly when x is large in comparison. So your power function is not going to increase as much. So for the power function, actually, let's see here. X raised to the e. Well, it's gonna be less. Almost any time you have the x and the exponent, it's going to increase much more rapidly. Okay, that's it. All right, so this, let me just write this out. So this is e raised to the x, and this one right here, roughly, is x raised to the e. Okay.